Hi everyone! As maybe you can hear, my voice sounds a little bit strange. This is because I'm a little bit ill, but nevertheless I will do this video. And as I promised last time, this week we're going to continue with the building of the 3D printed robotic arm. And we already finished all the hardware, and today we're going to take care of the electronics. And if everything is gonna be okay, today we're gonna make some basic move with this robotic arm. But before we continue, if you're new to my channel, please consider to subscribe to my channel, and also please consider to support me on my Patreon page. This will help me to develop new projects like this one, or even better than this one. So let's get started. The first thing which we should do is to solder the sub-D connector over here. I already separated the wires for each motor. Like for example, this is for the axis number 1, axis number 2, axis number 3, etc, etc. So like this it would be easier for me to solder them, and afterwards this connector is going to be fixed just here. So let's do this. To solder wires, I started with the motor of axis number 6, afterwards I went to the axis number 5, axis number 4, pin 13 stays not connected, afterwards I soldered the axis number 3, 2 and 1, and also on each of this wire I put the heat shrink tube in order to assure that there is no any short circuits between these wires. So now when the soldering is done, what is left is just to fix this connector to the body of the robotic arm with the screw and nuts. So now we're going to test this robot arm with the old electronics, with the electronics from the previous robot arm. And I should say that this electronics, you should not switch it on without motors connected, because this Trinamic steppers, they don't like when they're switched on without motors. They can go crazy and burn themselves. So first of all, connect now the power. Okay, this is the main power. Main power on, and switch on, and let's hope that it's gonna work. Nice! So second axis works, so the axis works. Fifth axis works. Fourth axis works. First axis works. And sixth axis works. Everything works. Perfect. Nice. Cool. The electronics inside this box is based on Trinamic drivers, and this is quite expensive setup. So the electronics inside this box cost around $400 US. So I think that it's better to test something, some cheaper solution, because this one, I don't think that this robotic arm needs this expensive solution. So here we're going to build another electronic box, another driver for the robotic arm. And for this I have these three drivers. This is a TB6600 drivers, and these drivers is gonna drive axis 1, 2 and 3. And also I have 3 DRV8825 drivers. They're gonna drive axis number 6, 5 and 4. And also I have Arduino Mega and a RAMPS board. All this setup is gonna cost around $70. And so let's see if this cheap version is gonna work well. So for this I printed this support. This support should hold 3 drivers over here, and also Arduino over here. Something like this. So let's assemble it. So let's start with something simple. Fit. The next, let's fix these drivers. Nice. Next we're going to fix Arduino, and Arduino goes here. To fix Arduino I'm going to use these plastic washers. On top of the Arduino goes a RAMPS board. This is close view on the RAMPS module, and you see I installed one driver DRV8825. So this is DRV8825, and there is one jumper on this position, and this position of the jumper corresponds to the 16 microstepping. And next step is to wire everything. So to wire these drivers to the Arduino, and also to wire the sub-D connector which will go to the robot afterwards. So on this electronics I connected the power. These two wires should go to the power supply, and the power supply should be between 12 and 20 volts. So these 2 wires goes first of all to the RAMPS to power up RAMPS board, which will power up the drivers DRV8825, and also it is going to power up Arduino here. Afterwards these 2 wires, so plus and minus, they go to the TB6600 drivers, goes to the power here, here and here. And now I can explain you the full schematics. So this is the schematics of this electronics when it's gonna be finished. And here there is Arduino Mega. There is these 3 drivers DRV8825. Each of these driver is gonna drive the stepper number 6, so the axis number 6, 5, 4, 3, 2 and 1. Afterwards there is also 3 drivers TB6600, 1, 2, 3. And these drivers, they are more powerful, so they're gonna drive the axis number 1, 2 and 3. So how the connection is done? First of all, Arduino sends the direction signal to each driver, and also the step signal. So there is 2 signals here, 2 here, 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 here and here. And afterwards also Arduino sends a signal enable. And this signal will allow me to switch off the drivers, and like this the motors is gonna be switched off and they're gonna cool down during this time. So there is enable here, and also this enable wire over here. So it means that I can switch off either axis 4, 5, 6 or axis 1, 2, 3. And also this dashed line, it's encapsulate or this line enclose what is gonna be connected to the ramps directly. So like this, I don't need to make these wires, like these wires, for example, because all of this, all the wires for the power, because all of this is already included on the ramps. So the only wires which I need to do is these ones, and also the wires to each motor. Now the wiring is finished, and now I will show you the close-up of these wires. I have this 14 volts power supply which I'm gonna use. So let's connect it. Now I can set the current for each motor. So I set the proper value of the currents. These values you can find on my GitHub page in the PDF about electronics. So for the 3 axis 4, 5 and 6 the current is set by these small resistors, and for the axis 3 to 1 the current is set with these switches. So now we need to program and hope that it's gonna work. So in the original program I commented everything except the motion of the axis number 2. Like this, I will check axis by axis if it works. So, and I will start at from some neutral position. Okay. So this was the wrong direction, definitely. Okay, let's correct this. So I changed the direction of the axis 2 in the program. For this I just, in all the lines like direction 2 pin low, I changed to the direction 2 pin high, and all the direction 2 pin high I changed to the direction 2 pin low. Easy. So now let's flash this program. Done uploading, and we can test it again. Also, I will test it from some neutral position just for any case. Okay, it goes to the right direction. Looks like right amplitude. Okay, this part works. Now let's do the same with the axis number 3. So changes are done. Now let's do upload it. Done uploading. We will test it again from the neutral position. Okay, this is axis number 2 and axis number 3. Wrong direction again. Let's change it in the program. We already know how to do this. Changes are implemented. Now let's upload it. Done uploading. Let's test it again. So now we're gonna test that axis number 3 is working. This is right. This is correct. Nice. Now let's test the axis number 5. Uploading, done uploading. And let's test it from the neutral position. So I will keep it here. Second axis, third axis. And now the fifth, let's look. Okay, it goes up. It means that it's also wrong direction. Probably I should change all the directions. Uploaded the program to the Arduino, and in this program I changed the direction of all axes. Let's see how it works. Not exactly what I needed. Okay, I'm gonna check where there is a problem. I think I finally managed to solve the problem. I think the problem was with microstepping. I thought that microstepping on this DRV8825 was set at 16, but it was set at 32. So let's check. Now I need not to forget to take out this piece. Yes. So axis 2 seems okay. Axis 3 is still good. And axis 5 is okay too, so it should be fine now. Ooh, looks great. Still cold. Motors are cold too. I think we can call this success. It's more noisy, but this is what I was expecting. Nice! Thank you for watching this video till the end. And today we made two successes. The first one is that our new robotic arm is working. We tested it with old electronics, and also we built a new electronics, which is much cheaper than old one. Old one is cost around $400 US because it used Trinamic drivers, and this is a much less expensive solution. It costs only $70, and it works more or less the same. The only difference, obvious difference, which I see right now is that this electronics it's much more noisy. The motors with it moves noisier than with the Trinamic drivers. If you're new to my channel, please consider to subscribe to my channel. Also, I would like to say huge thank you to my patrons. Here's their names. Thanks to them I was able to make this project, and thanks to them I will do even more amazing projects in the future. If you would like to become my patron, please do this on my Patreon webpage, and see you next time.